Okay, so number 7 is pretty kind of interesting, kind of tricky to do. They say write an equation of the form y equals a times b to the x plus k for the graph above. Well, how do we do that? Well, in the notes, I just put this in the notes for you. These are the exam 3 notes. There it is right there. Wait, is that it? Write an equation of exponential. Yeah, that is it, actually. That is exactly it right there. So right there for you. Get that out of the way. There it is. I'm going to move it over here. There it is. Okay. Yeah, so here's the steps. How do you write an equation from a graph? Well, first off, you've got to identify the horizontal asymptote. And that's going to be k. That's the first step. So let's go back to this graph. Let's identify. So step number 1 is to identify what is the horizontal asymptote. Well, it's actually right here. My lines look a little funny. They really do, don't they? Yeah, let's try that again. It's right there. So there's the horizontal asymptote. Where's it at? -4. In other words, that's the leveling off line. See, it looks like our, remember exponential graphs always flatten out on one side, rocket up on the other. Sometimes they go the other way like this. They rocket to the right, flatten to the left. Sometimes they rocket down, flatten on the left, or flatten on the right, rocket down on the left. They can do all different things, but they always, exponential graphs, when x is in the power zone, always flatten on one side, rocket on the other. That's what they do. So if you find the flattening side, that's called the horizontal asymptote. So what is the horizontal asymptote on this one? Well, it's -4. And that is your k number. So when you have the equation, here's the equation right here. So y equals a times b to the x plus k. That tells you the number that's added or subtracted off to the right. That is your horizontal. You're calling it k, but what it is, we should call it horizontal asymptote. And I'll just make it plus a -4 is just -4. So that number added or subtracted off to the right is the horizontal asymptote. So there's the first step. We've got k. Now we got to find a and b. What do we do next? Looking at the notes. Next, it says plug in the y-intercept point to solve for a. Okay, let's go get the y-intercept point. So step 2. Plug in the y-intercept. What's the y-intercept? Well, the y-intercept is right here. It's where the graph hits the y-axis. Y-intercept, that's over 0 down 2, isn't it, that point? Over 0 down 2. That's an x value and a y value. So take our equation, our y equals a times b to the x minus 4. No, minus 4 in green now. And plug in our x value of 0 right there, and our y value of -2 right there. So we get -2 equals a times b to the 0 minus 4. Good so far. I've plugged in the x and the y of the y-intercept. So what becomes of that? Well, -2 equals a. Now, what is b to the 0? What is anything to the 0? 1. So this is -2 equals a times 1 is just a, minus 4, add 4 to both sides. And so a is 4 minus 2, a is 2. So now we've got a. A is 2. So now our equation, which is y equals a times b to the x minus 4, now we know a is 2. So now we've filled in a is 2. We've already got k at the back. All we got left now is to find b. And so that's the next step. And step 3, plug in the x-intercept to solve for b. So now let's do that. So step 3. Plug in the x-intercept. Now what's the x-intercept? It's right here, isn't it? See it right there, where the graph hits the x-axis. What's the coordinates at that point? -1 up 0, back 1 up 0. Remember how that works? That's so that's an x value and a y value. So I'm going to take the equation that we have right now. Y equals 2 times b to the x minus 4. And I'm going to plug in x is -1 right there, and y is 0 right there. So 0 equals 2 times b to the -1 minus 4. So I plugged in the x and the y, so now I'm going to solve that equation for b. So I'm basically taking the graph and observing things about the graph in order to find the k, the a, and now the b. That's the plan. Yeah, good question, Christian. Yeah, if the graph goes through 0, 0, then that is both the x-intercept and the y-intercept. Great question. Yeah, use that. If the graph happens to go through 0, 0, then that is both the x-intercept and the y-intercept, because that's where the graph hits the x-axis and the y-axis.
What if you can't tell what the x-intercept is on the graph?
Oh, really?
Yeah, mine doesn't cross like at an exact point.
Mine is half, I'm pretty sure.
What's that, Carlos?
Mine also is, I think it's half, like 0.5, where it crosses.
I think they would have to show you. I can't think. Yeah, well, basically, yeah, if that isn't clear, good question, grab any other point that is really clear. It doesn't have to be an x-intercept or y-intercept. That'll make things easier. But if it doesn't have to be, it can be any other point that's really, really clear. Now, what do I mean by clear? Has to go exactly through an axis, but like look right here. See how this point right there is clear? Because that hits right on the grid marks. That looks like it's over 1, down 3. I could use that point instead of this x-intercept. That'll work just as well. Yeah, okay. Good question. So it doesn't have to be an x-intercept. It can be some other point, but grab a point that's clear. Yeah, if you can't tell for sure about the x-intercept, then use some other point. Yeah, maybe I'll do that to, well, here, I'll do both. Let me finish up this way, and then I'll also do it that way. So plug in the x-intercept. So this is going to be 0 equals 2 b to the minus, oh, wait, I'm not changing anything. Let's add 4 to both sides. I'm trying to solve for b now. And we get 4 equals 2 times b to the minus 1. And then divide by 2. Boom. B to the minus 1 equals 2. We're good to there so far. Now we want to turn that into normal b, right? I'm trying to solve for normal b. Well, how do you do that? Well, you're going to have to raise both sides to some power that'll make this down here be normal b. Well, when we say normal b, we mean b to the positive 1, don't we? Because b to the 1, that's just b. That's normal b. So basically, I have to make that power change from -1 to +1. So what that means is I have to do a -1 power on both sides, right? Because -1 times -1 makes +1. Is that good there? Powers outside parentheses multiply powers inside parentheses. So -1 times -1 is +1. And then what happens on the other side? Remember what negative powers do? It flips it, and then the power becomes positive. That's a half. So b to the +1, or just b, is a half. Again, negative powers are negative. They're unhappy where they're at. They want to flip it to the other side. Then they are happy. Then they're positive. So it's 1/2 to the 1, or 1/2. So b is a half. So we got our b. So then our equation is, grabbing it right here, our equation, which was y equals 2 b to the x minus 4. Now we know what b is. B is a half. And there's our equation. Now, let me show the other way. In case you don't have a good x-intercept and you have to use that other point, let me show that also. So it's a great question. So what if instead you can't tell your x-intercept? Well, then you have to use some other point. Like I'm saying right here, you can use the point 1, -3. There's nothing especially magical about the x-intercept. It's just a clear point. So you can use some other clear point. Let me redo it. Let me pretend I didn't just do number 3. Let me redo number 3, starting from here using this other point to show you how that works. So here we go again. So number 3, I'm going to plug in, what was it? Over 1 down 3. Let's make sure that's right. Yeah, over 1 down 3 to the equation that I had right before I found the last part. Y equals, what is that? 2 b to the x minus 4, right? 2 times b to the x minus 4. Now, hopefully I get the exact same answer, or math doesn't work. And we know math works because it's a made up field, made up to be consistent with itself. So it always works. It's not anything amazing. It's made up that way. So x is 1. So plug in x is 1 and y is -3. So there we go. So I plugged in x is 1, y is -3. What do we get? Well, we get -3 is 2 times b. B to the 1 is just b. That's no big deal, right? B to the +1, that's just b. So add 4 to both sides. I wonder if we're going to get the same answer. So actually, I don't wonder. I see that we are. You probably do too. 2b, last step, divided by 2. Isn't that beautiful? Same answer. B is a half. Same thing we got right here. B is a half. So any clear point will work. Doesn't have to be the x-intercept. You could do any other clear point. Doesn't have to be the x-intercept. In fact, that was in some ways easier to deal with, over 1 down 3. So that works. And there's our equation. So one more time, let me run over. How does this work? This wasn't easy for sure. First off, we had to identify the horizontal asymptote, which was right here, the flattening outline of the graph, which was at -4. That's your k at the back, the horizontal asymptote, where the graph flattens out right here. You know, where the graph flattens out at -4, that's your number at the back, your k, the number added or subtracted at the back. And then plug in the y-intercept to find a. Now that you should actually use the y-intercept because that's nice. So plug that in. I did it. I was able to find a. So now we know k and we know a. We've come to this point. And then just plug in any other point that's clear on the graph. You could be the x-intercept if they made that clear. If not, just plug in some other point that's clear and you'll be able to solve for b. And then you'll have the whole equation of that graph. So you're able to work backwards from a graph back to its, an exponential graph back to its equation.